Okay. In unit number 4, syllabus is there. That is synthesis of 4 accuracy point and compatibility equation. Then complex numbers method of synthesis, diad, center point, circle, ground pivot specification, 3 accuracy point synthesis using diad method, and advanced synthesis of mechanism. This is the syllabus in this. Today what we are going to see is precision points. Before that, we should know what do you mean by analysis of mechanism and what do you mean by synthesis of mechanism. We know that in case of analysis, the determination of displacement, velocity, acceleration for the given proportions of the mechanism we are going to find. Means you will have given a mechanism, and of that mechanism, what will be the displacement of any link, what will be the velocity of link, what will be the acceleration of any link, that parameters we have to find. That method is called as analysis of mechanism. And in case of synthesis, it's a synthesis exactly opposite of that of the analysis. In this case, you will have given some requirement, what the output is required. And in order to achieve that output, you have to design the mechanism. That is nothing but the synthesis. In this, we have to design a certain mechanism to produce a desired output of the motion. Means sometimes they may have given that input is suppose like this, what we can say, X parameter is there to the mechanism. And they have given that at output Y is required. Suppose they have given Y is equal to sin X, what they required. At that time, X parameters you have to put as an input, and Y is equal to sin X as output should get. And for that purpose, you have to design the mechanism. You may have learned that is CAM and follower. In case of CAM and follower also, what they have given the which type of motion we require at the follower, and as per that we have to define we have to draw the CAM what we can say profile. That is nothing but also a synthesis. Same case. Now synthesis process is done in 3 steps. First step is type synthesis, second step is number synthesis, and third step is dimensional synthesis. In case of this, type synthesis is a first step in a synthesis. What it means suppose they have given that we required some type of output. For that purpose, if required in order to achieve required output, which type of mechanism we have to select, which type of mechanism, which type of drive, which type of what we can say linkages we have to select, that comes under time synthesis. Means whether we have to use belt drive, whether we have to use gear drive, whether we have to use cam and follower, whether we have to use motor drive, or whether we have to use any type, any type, which we have to select in order to get the required output. That is comes under type synthesis. Means in synthesis, our first step is type, which type of mechanism we have to select. Second step in a synthesis is number synthesis. What it indicates? It indicates how many number of links you required in order to get the required mechanism. How many number of joints you required, whether that joints are ternary joints, tertiary joints, binary joints, that we have to select as well as we have to count it. Also we have to count, also we have to think that how many degrees of freedom it required in order to achieve the required motion. That comes under number synthesis. Means this is second step in case of synthesis, and third step is dimensional synthesis. In this case, we have to actually find out the dimensions of the mechanism. Means link length, we have to find out that how much long link is required in order to get the required output. Sometimes we require the complete rotation. At that time, how much amount of link length will be there. Sometimes suppose we have to achieve some ratio. For that purpose, how many number of teeth are required on gear in order to achieve the required ratio. That comes under dimensional synthesis. What will be the dimensions of the different linkages, different parameters of the mechanism. That comes under dimensional synthesis. Means synthesis process consists of first step type synthesis, second step number synthesis, and third step is dimensional synthesis. Now, in designing mechanism, one factor that must be kept in mind is that the accuracy required of the mechanism. Whatever the output we require, that should be within the range. It should achieve to the maximum accuracy, means minimum error should be there. Sometimes it is possible to design mechanism that will theoretically generate the given motion. Theoretically, it's okay to give, theoretically it will achieve the exact motion what we require. But actually in practical, it is not possible. For that purpose, the difference between the desired motion and the actual motion produced is known as structural. I have explained right now that whenever required motion is given, required function is given, at that time, whatever we have designed the mechanism, at that time, 100% it will not achieve the required output. It may get at some points. That points are called as accuracy point that we will see later on. But in between that, they are not following the required one. They are not exactly matched with the required output. That's why that error is called as a structural error. But it is not the case that in mechanism only structural error is there. There may be some mechanical errors are also there. That mechanical errors are nothing but what? Errors due to manufacturing, errors resulting for the tolerance due to the tolerance for the length of the links, bearing clearance. Because of that, whatever the error induced in the mechanism, that error is called as mechanical error. Now, these syntheses are classified as function generation, path generation, and body guidance. These three difference are there. That this total path generation is also there, body guidance is also there, function generation also there in our syllabus. If you have studied unit number 3 over there, you may have studied path generation. In some cases, body guidance is there. In some cases, function generation is there. What do you mean by function generation? Means you will have given the output in terms of a function. Suppose, take an example, they have given y is equal to sin x. Function is given, y is equal to sin x. You have to follow output in, or you require output in the term such that y is equal to sin of x. Means what? X input you have to give to the mechanism, and at the output you require sin x. Means some type of curve you require, some type of function you require. In order to follow that, whatever the mechanism you have derived, that comes under function generation. In case of path generation, it should follow the required path. Means suppose take an example of mechanism of copying, suppose pentagraph, you know that. What it does, at some point it follows some path, suppose, and output it gives you the enlarged path. That comes under path generation. Means output should follow a particular path, particular curve. You have studied coupler curve. What that coupler curve? What is over there? There also a point is there, and it follows the particular curve, particular path. It comes under path generation. And in case of body guidance, total body, each and every point on the body should follow a particular path. For example, on dining table, you may have seen that what we can say, that pots are moving along a path to the different position, we can say. That mechanism comes under body guidance. In case of function generation, designing of mechanism, the frequent requirement is that the output link should either rotate, oscillate, or reciprocate according to the specified function of a time or a function of a motion of the input link. Right now I have explained, suppose we require function y is equal to sin x, sin theta, sin t, that are the function in terms of time, in terms of theta, in terms of displacement of a input link. This is, if the output link follows the given function, at that time that is called as the function generation. X is the input and y is the motion at output. So suppose y is equal to f of x. F of x, that may be a sin x, cos x, tan theta, whatever, in terms of a function. I have explained that Kalman follower. In case of Kalman follower, you will have given the output at what? Output at follower. follower in terms of function is given. That is in terms of sine theta, in terms of sinusoidal curve, or in terms of that 3 degree. That term is given in terms of follower output in terms of a function. At that time, by taking that under consideration, that follower should follow this function. For that purpose, what will be the shape of cam? Whenever we have to derive that, whenever we have to synthesize that, that methods comes under function generation. Now path generation is there. I have explained that in this case, mechanism is required to guide a point called as a tracer point, or we can say a coupler point, along a path giving a prescribed shape. I have explained right now that in order to copy, suppose we have to enlarge the view. At that time, copying mechanism is there. That is, I think it is called as a pantograph. What it does, at some point is tracing a particular path over here. At that time, at the end over here, at the end, some it miss this displacement in terms of length. It will be get doubled or whatever you can say. It follows the path. That type of mechanism is called as a path generation. For example, pantograph. Now body guidance. In case of body guidance, both the positions of the point within the moving body and the angular displacement of body are specified. The problem may be a simple translation or a combination of translation. Right now I explained, suppose this one is a link they have given. That link, it moves, or we can say it rotates about some point. At the same time, it's a translation as well as rotation is there. Means at this time it is supposed straight line. It goes towards this, it is rotate about, it's as well as translate. At that time, which path should be there, how much linkages are required, what will be the link length, that comes under body guidance. From that, first of all, we will think about the precision point I have explained right now. That whenever we have designed any mechanism, at that time that mechanism does not follow 100% the output, but it match at some points. The point at which it matches with the required function, that points are called as precision point. Take an example. Suppose in this case, you have see over here, the dark one is a path which is prescribed, which is required one, and a dotted path shown over here that are the actual generated function. In this case, this actual generated function and prescribed path doesn't match 100% from x0, y0 to xn plus 1, yn plus 1. It doesn't exactly match, but it matches at some points. See over here. At x1, y1 it matches, at x2, y2 it matches, at x3, y3 it matches, and at xn, yn it matches. And this point, the point at which this actual generated function and prescribed function matches, that points are called as precision points, or it's also called as a accuracy point. Precision points are to be located in order to minimize the error between the points. I have explained that mechanical error is there as well as structural error is there. These errors, in order to minimize, we have to derive or we have to synthesize a mechanism in such a way that it will passes through the maximum point in between the given specified space, or we can say the range. The structural error are present even if there is no graphical error or mechanical error. The amount of structural error in the solution can be affected by selection of precision point. Right now, I have explained that in order to minimize the structural error in between the specified space, in between the specified range, we have to select the precision point, maximum precision point, 2 point, 3 point, 4 point, that are in order to reduce the error. For locating precision points in 4-bar mechanism, Chebyshev spacing methods have to be used. What do you mean by this Chebyshev spacing? Best spacing of the precision points is called as Chebyshev spacing. According to Freudenstein and Sender, the Chebyshev spacing for endpoints in the range XS starting point is less than x is less than xf, that is nothing but the final point, is given by equation xj is equal to 1/2 xs plus xf minus 1/2 xf minus xs cos of pi 2j minus 1 upon twice n. In this case, xj over here, this is xj. Xj indicates the precision point. Means first precision point, second precision point, third precision point, fourth precision point. This j indicates number 1, 2, 3, 4 up to n. How many number of precision points you require? Xs is what? Starting point of a given range. See over here, xs is less than x is less than xf. In between them, we have to find out the precision points. So xs is the starting point, xf is the final point. Minus 1/2 xf minus xs means delta x. Given range. Final minus initial. Into cos of pi 2j minus 1. J is what? If we are finding first precision point, then 2 into 1. If you are finding second precision point, then 2 into 2. That is 2j minus 1 upon twice n. Twice n is what? How many number of precision points you require? 3, 4, 5. That's where xj is the precision points, xs is the starting value, xf is the final value, and j are 1, 2, 3, 4 up to n. How many number of precision point you require? That is nothing but the n. Remember, while doing calculation, in this case, this cost term is in radian. This cost term is in radian. Either you have to convert it into degree, means multiplied by 180 by pi, and then do calculation in degree mode in your calculator, or otherwise keep this as it is and do calculation in radian mode. That is required. Otherwise, your answer will not match. Remember, this term is in radian mode. That's why either you have to convert it into degree mode and do the calculation in calculator in degree mode, or otherwise put it in radian mode as it is and convert your calculator in radian mode and then do the calculations. Now the precision or accuracy points may be easily obtained by using graphical method. No doubt, in this case, you can find out 3 precision points, 4 precision points, 5 precision points by analytical method. I have explained right now that xj is x1. If you are putting x1 means first precision point, you are going to find x1. At that time, j has to be replaced by 1. 2 into 1. X is equal to 2 means second precision points. At that time, 2 into 2. And this n is what? How many number of precision points you required? 3 precision point, 4 precision point, or 5 precision point. It may be defined in a problem. Suppose we have to find out 4 accuracy up to 4 precision points. At that time, this n is equal to 4 and j will vary from 1 to 4 like this. In this case, you are doing analytically, but the same problem can also be found by graphical method. In case of graphical method, what we required how many number of points we required? Precision points. They have mentioned in a problem that find out up to 4 accuracy point, 5 accuracy points. Means n you know. Then you required a range, that is starting point and final point. That is given in the problem. You may have seen. For that purpose, in case of graphical method, first of all, we have to draw a circle of diameter equal to range. जैसा जो भी आपको रेंज दिया जाएगा, xf is less than x is less than, sorry, xs is less than x is less than xf. तो आपको xf minus xs आपको रेंज मिलेगा. उस रेंज का you have to draw a circle. You have to draw a circle. See over here, that circle having diameter is equal to range. Right? Then you have to inscribe a polynomial into that. Suppose you have to draw a or you have to find out a 3 accuracy point. बराबर means x is equal आपका कितना n is equal to 3 बना. So n is equal to 3, so you have to inscribe a regular polygon having number of side equal to twice the number of precision point. अगर 3 precision point तक निकालना तो you have to inscribe a polynomial having twice n sides. 3 है तो 6, 3 into 2 6. तो 6 side वाला means what? Hexagon. You have to inscribe a regular hexagon. If you have to find out up to 2 precision points. So number of sides of the polygon 2 into 2, that is 4. So you have to inscribe over there at a rectangle. In this case, suppose you have to find out solution up to 3 precision points. So अपना polygon बना regular, polygon बना hexagon. So you have to draw a hexagon in the given circle having diameter equal to range. Remember? And then from each and every corner, 1, 2, 3. 1, 2, 3. From that, you have to draw the perpendicular on the diameter, center diameter. This corner say AI x1, this corner say AI x2, this corner say AI x3. Just measure that, multiplied by scale, you will get the exact value. जैसे वहां पे हम लोगों ने क्या किया, कैलकुलेशन किया x1, x2, x3 by replacing j. In this case, there is no need. You have to draw only circle. You have to inscribe the polygon having number of sides equal to twice n, and from each and every corner you have to draw the perpendicular on a diameter. आपको मिला x1, x2, x3. उसकी वैल्यू आपको कैलकुलेट करना है. तो ये अगर इसको अगर आप लोग स्केल से इस डिस्टेंस को स्केल से मल्टीप्लाई करता है तो आपको x1 मिलेगा. इस डिस्टेंस से स्केल से मल्टीप्लाई करते हो आपको x2 मिलेगा. और यहाँ से इस डिस्टेंस को स्केल से मल्टीप्लाई करते हो आपको x3 मिलेगा. अगर आपने स्केल सिलेक्ट किया रहेगा तो इफ यू हैव ड्रॉन इट टू द फुल स्केल, no need to multiply by scale, just measure this distance. That one will be x2, this distance will be x2, and this distance will be x3, considering this as a origin. See over this as a origin. A vertical axis है and a horizontal axis है. On that horizontal axis, whatever the perpendicular you are drawn, you have to get this value. That will be the precision point x1, x2, x3. Draw perpendiculars from each corner in order to get the respective values of precision point. This is the graphical method. First one is the analytical method. If you have any problem, you can ask in between them. If you are not understanding.
Sir, I have one question. Sir, तेजलिए. So sir, previous diagram पे जाइए ना. तो उसमें the graphical method.
Okay, just a minute. डाउट रहा तो पूछना है बीच में है. हाँ बोलो.
तो इस ग्राफिकल मेथड में आप x1, x2 और x3 की वैल्यू xs से मेजर करते हैं.
हाँ, xs से मेजर करना.
हाँ, तो x2 will be always the radius of the circle.
Because what? X lie in between xs and xf. That's why we have to measure from xs.
Okay, then x2 will be always the radius of the circle.
Not necessary. Right now it is hexagon, that's why it is equal to radius. If it is pentagon, if it is a heptagon, at that it will be different. In this case, you have to find out up to 3 precision points. That's why we have drawn hexagon. If it is up to 4 precision points, then we have to draw octagon, regular octagon. And then from each and every corner, we have to draw perpendicular.
Okay, but so for the pointing these sides of the hexagon, you have to randomly start, or you are starting from the topmost diametral point?
Length of side or what?
No. To mark these hexagon sides, we are starting here from the top diametral point.
Yes. Because what?
So
see, in this case, number of sides are what? Even numbers.
6.
Because it is twice n. Right?
Yes.
That's why, as it is even number, definitely one side should be perpendicular to the x-axis. And in order to put this one side perpendicular, you have to draw from top side, so that side will be perpendicular to x-axis.
Okay.
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 Anything else?
No.
Okay. Now, it is not the case that each and every time only function we have to follow. At that time, it's a displacement also we have to we have to take under consideration. That is called as angle relation for the function generation. Consider a 4-bar mechanism as shown in figure to generate function. In this case, to generate function y is equal to f of x. Means this one is the input. Suppose this one is a 4-bar mechanism, A, B, C, and D. In this case, how much amount of displacement to the input link is given in between XS and XF. यहाँ पे थोड़ा मुझसे गलती हो गई. It is YS and YF. Output should be in terms of Y and input should be in terms of X. So XF at that time output will be from YS to YF. At that time this input link may have a displacement theta S, theta F, theta 1, theta 2, theta 3. It depends. As per that, output link will have also some angular displacement in terms of phi S, in terms of phi up to phi F, and that is nothing but phi S से लेके phi F तक और phi F से लेके phi S तक. ये हुआ थीटा डेल्टा phi. Similarly ये होगा डेल्टा थीटा. Similarly ये हो गया डेल्टा x and ये हो गया डेल्टा y. यहाँ पे थोड़ा सा कंसिडर करो. This one is ys and this one is yf. थोड़ा सा मिस्टेक होगा यहाँ पे. This is ys and yf. Now range in x is xf minus xs. Corresponding range in theta means input angle, angular displacement, theta f minus theta s. थोड़ा सा अपना 10 minutes are remain in a lecture. But if it is get disconnected, remember just within 5 minutes, again join the same link. We will continue then. आपको 5 मिनट में once again join करना है अगर disconnect होता है तो. Means xf minus xs is the range for the displacement at the input in case of linear, and theta f theta s is the angular range for the input line. Similarly, for output, range for the y is from yf to ys and same angular displacement yf to, so phi f to phi s. The relation between x and theta and y and phi are as. We had to find out x as by using the formula xj is equal to, abhi maine aapko bola that you have to do in radian mode. Similarly, same using that x, we can find out the relation in between theta angular displacement of input link, that is theta j, for first precision point x1 theta 1, second precision point x2 theta 2, third precision point x3 theta 3. Same x1 x2 x3 will get replaced and you can find out the theta 1 theta 2 theta 3. For that purpose, theta f theta s theta s, these things are given. This is the range for the input angular displacement. This is the range for the linear input displacement, and this xj minus xs, they have given that. I think yesterday Nikhil have asked me about this theta and phi. So this relation is there in this case. Now same for phi also, for output link, phi j theta s plus phi s plus phi f minus phi s means range for angular displacement at output link, range for linear displacement for output link, or function range we can say yf minus ys, and this yj minus yf. Agar phi 1 calculate kar rahe ho, over here y1 will be here. Phi 2 calculate kar rahe ho, over here y2 will be there. Now we'll solve some problem. Yesterday मैंने आपको शायद बोला था कि calculator and that thing should be there with you. So suppose one mechanism is given, one problem is given, a 4-bar mechanism is to be designed by using 3 precision points to generate a function y is equal to x raised to 1.5. For the range, 1 is less than or equal to x is less than or equal to 4. Matlab xf and xs. xs is equal to 1, xf is equal to 4. Assuming 30 degree starting position and 120 degree end position. Means starting means theta s. Theta s is 30 degrees given, and final range theta f. For input link, that's why I am taking theta. Theta is 30 degree, theta f 120 degree. Finishing position of the input link and 90 degree starting position and 180 degree finishing position of the output link means phi f and phi s. Phi s they have given 90 and phi f they have given 180. This is the finishing position. Find the values of x, y, theta, phi corresponding to the 3 precision points. Means we have to do the calculation for three precision points. Means we have to find out x1, we have to find out x2, we have to find out x3 by using the formula that I have explained. With the help of that x1, x2, x3, we have to find out C over here. We have to find out y1, y2, y3 by putting y1 के लिए x1 पुट करना है, y2 के लिए x2 पुट करना है, y3 के लिए x3 पुट करना है. आपको मिलेगा y1, y2, y3. सिमिलरली आपको xf मालूम है, xs मालूम है, xs मालूम है, xf मालूम है. तो you can find out ys, yf. बराबर. With respect to that, you can find out theta s, theta 1, theta 2, theta 3, and theta f. Similarly, we can find out phi s, phi 1, phi 2, phi 3, and phi f. That are the things which we have to find out. Given things, xs is equal to 1, see, xs is 1, xf is equal to 4. Theta s is given, starting value for the theta 30 degree. End value for the theta, that is final value for the theta is 120 degree. At the output, starting value is 90 degree phi s. Output value, final value is 180 degree. Theta f is equal to 180 degree. These are the given things. Three values of x corresponding to the three precision points. That is n is equal to 3. They have given over here for three precision points. The n is equal to 3. According to Chebyshev spacing, that are given by xj is equal to 1/2 xs plus xf minus 1/2 xf minus xs cos of 2j minus 1 upon twice n. Whenever we have to find out x1, see over x1, at that time j will be 2 will be multiplied by 1, 2 into 1. X is equal to 2, matlab x2, second precision point. At that time 2 into 2, 4 will be there. And in this way you have to find out x1, x2, x3 है. तो आपके पास कैलकुलेटर रहेगा as well as नोटबुक रहेगी. तो बोलो मुझे x1, x2 कितना आता है आपका, फटाफट कैलकुलेशन करो और बोलो मुझे. x1 करो कैलकुलेट, y1 कैलकुलेट करो. है सबके पास नोटबुक है ना? हेलो.
हाँ सर.
हाँ, 4 मिनट में आपका टाइम खत्म होने वाला है. अगेन आपको ज्वाइन करना है वंस अगेन, 1-2 मिनट के अंदर ही. या तो आप लोगों को कैलकुलेटर रेडियन मोड में कन्वर्ट करना है, या तो कॉस वाली जो टर्म है, ये अंदर वाली जो टर्म है, इस टर्म को 180 बाय पाई से मल्टीप्लाई करना है. तो पाई पाई कैंसिल हो जाएगा, ये टोटल डिग्री मोड में आ जाएगा. तो डिग्री मोड में रख के कैलकुलेशन करो, या तो ये एज इट इज रखो और कैलकुलेटर रेडियन मोड में ले लेना, आंसर बराबर आ जाएगा. x1 कैलकुलेट करो पहला और बोलो मुझे कितना आता है.
x1 1.2.
वेरी गुड. सबका आता है क्या उतना? x1 आ गया 1.2. वेरी गुड. x2 कैलकुलेट करो, x3 कैलकुलेट करो. अगर किसी को कुछ दिक्कत आती है तो बोलना है.
x2 2.5.
x2 कितना है?
2.5.
2.5. Very good.
x3 3.